Hello, everyone. My name is Liz Klein. I am from the GEO Program Office, and welcome to the Satellite Book Club Seminar Series, session number 223. Today's presentation is on satellite demonstrations from the 21st of May, 2024 during the Hazardous Weather Testbed. It will be presented by Kevin Thiel, a research meteorologist from CIWRO, and the GOES-R Satellite Liaison to SBC and HWT. Our facilitator today is Jessica Bunker from CIWRO and the Warning Decision Training Division. I'd like to remind everybody online that this session is being recorded. Per the OCIO Privacy Act guidelines, please keep your microphone muted and webcam off throughout the session. See the pinned message in the chat for more information. The Q&A section will be after the presentation. I would like to encourage attendees to post their questions in the chat room and they will be fielded through there. If you are logged in under an alias, please sign in with your full name or specify your full name when asking a question in the chat. We are always looking for future presenters. Please contact the Tower S team if you're interested in presenting. The training team can help create training materials that may be unavailable. Contact Ross Van Thiel for information or questions about that. Finally, thank you to the OCLO, the GEO and LEO programs, and our facilitator, Jessica Bunker. Okay, Kevin Thiel is a research meteorologist for the University of Oklahoma CIWRO, serving as the GOES-R Satellite Liaison for the Storm Prediction Center and NOAA's Hazardous Weather Testbed. He leads the Satellite Proving Ground HWT each spring and works with SBC forecasters to integrate satellite data into operations. Additionally, Kevin is a Meteorology PhD Candidate from the University of Oklahoma's School of Meteorology, studying operational applications of the GOES-R Geostationary Lightning Mapper. Kevin, welcome back to the SBC.
Thank you, Liz. And yeah, thank you all for having me again here to the Satellite Book Club. I'm really excited to talk to you all about a really unique day that we had on May 21st, 2024, and all the different products we were able to demonstrate on that day in the Hazardous Weather Testbed. So we can advance to the next slide and we'll just jump right on into it. So for those who maybe aren't as familiar with the Satellite Proving Ground, you might hear it also called the Satellite Convective Applications Experiment. It has a few different names, or just the Satellite HWT for short. The goal of this testbed is to demonstrate new satellite products for severe weather and decision support applications. So we cover everything from data quality to training, display, future research and development. We try to cover a wide swath of different goals and targets for providing feedback related to various satellite products, covering a wide variety of research readiness levels. Last year, we had 3 weeks of demonstrations, which is our typical to do. We had 2 in-person weeks where we brought in 4 forecasters each week into the Hazardous Weather Testbed, that physical space you see up there in the top right. And then we had 1 virtual week as well with 8 forecasters during that virtual week. We can split the forecasters up into groups, and then because we're using a cloud-based AWIP system, we can have the forecasters localized to different weather forecast offices across the country in our simulated WFOs. So we really are able to go where the weather goes. And because we run in May and June, we do live weather, so we are working in real time, trying to simulate that the operational urgency, and also providing for both the forecasters and the developers the chance to watch their products in action when they don't know what's going to happen next. We then collect data from our forecasters through quite a few methods. The biggest ones that you'll see today are surveys, blog posts, and group discussions. And especially those blog posts, we can gain a wealth of information from the forecasters and kind of these journal-like entries that they're able to provide us. So we can advance to the next slide now. When looking at that pattern as we came in that morning on May 21st, 2024, we noticed pretty quickly all hazards were in play. So when looking at the right image here, this is from the 500 millibar height analysis from the SBC mesoanalysis tool. We can see that long wave trough here out in the west. We also can see a short wave trough there, kind of or on the eastward side there. slightly downstream, but also coinciding with that 500 millibar jet streak, peaking at about winds of, I believe I'm seeing about 80 knots or so from that image. On the left there, we can see at the surface, though, we have a surface cyclone there in southeastern Nebraska. We also can see a subtle warm front feature as well across northern Missouri into southern Iowa, and then a cold front there stretching southward across central Kansas into Oklahoma as well. As we can go to the next slide now, we can see the surface cyclone now at 850 millibars there. You also can see those green contours for the moisture fields as that moisture is being pulled northward up into the Iowa-Missouri region, closer to the center of that low as that low continued to deepen. All these images are from around 16Z, which is roughly when we're kind of starting off operations and starting to look at the weather for each day. So we knew right away, just based on having the shear, having the lift, and the instability, we had a pretty strong setup for this day, and one that had some pretty strong synoptic forcing already available. We go to the next slide now. This is kind of what happened. I'll kind of give it away early for you, and you may already know this event, but this day provided kind of a mixed mode here, where you had this kind of linear system with lots of embedded supercellular structures, providing, as you can see on the right image there, when looking at the outlook categories and then also the reports, just a variety of hail, wind, and tornado reports throughout this region as well, especially looking there in central Iowa and northern Missouri. You can see there was a moderate risk from the 1630 outlook there from the SBC that morning. We go to the next slide there. We'll show you then this is the MRMS hail tracks there from the mesh product. I like to look at this product as kind of a one-day overview of where did our major storm tracks go, and you can definitely tell that we had some pretty intense, long-lived thunderstorms up within this enhanced and moderate region. So advancing now to the next slide, what you'll be able to, looking at that image, we already know where we had development and the growth. We also can see from the SBC 1630 outlook there that we had a significant severe weather noted in every category there, with I think that seen about 40% hatch or 45% hatch, the 15% hatch there as well, and then another 40% hatch too. So the notice severe weather of significant severe weather was absolutely there with the ingredients. We won't go too much more into those details. But the question became, where should we place our forecasting teams? So if we advance one more here, you'll see that we placed our forecasters in the Des Moines and the Kansas City county warning areas. We placed them there. We knew that we had a really good idea based on the cams that morning that the forecasters were going to impact severe weather, are going to have impactful severe weather in central Iowa. The timing and the intensity for a little bit further south in Kansas City in that CWA was a bit less certain. And so we wanted to kind of give ourselves a bit of a spectrum on that day. It was a pretty easy decision. Some days are a lot harder than others in the test bed, but this one worked out quite well for us. So if we advance one more here, the question that we're going to be asking today is, how did the experimental satellite products perform on this day? We were able to test all 5 products at once. And then how is this reflected in the overall experiment results? So I'll be talking about examples from this day and then relating it back to the overall feedback and the results that we ended up getting from the test bed this year. So as we go to the next slide here, I'll be going through each product, giving a quick kind of introduction and then explaining how it was applied on each day. So we're going to start with the Geostationary Lightning Mapper background and data quality product. The data quality product is there on the top right. This provides information such as the flash detection efficiency in the blue and green fill in that you'll see there in the background image there. And then you'll also see some artifacts that can show up there and some yellow and white pixels. These are pixels that are near or at saturation. I know Joseph Patton and Eric Bruning have talked about this in a previous satellite book club. I'd encourage you to check that out. Also, you'll see the GLM background image. This is the background image taken by the GLM every 2.5 minutes. We had the data every 5 minutes. And this is the reference image that the GLM uses in order to look for the rapid changes in pixel brightness to pick up on the lightning flashes. So looking at this image of how do we assess the GLM data in real time, and if the background image even on its own provides information as well to the forecaster. So going to the next slide to show how this worked out, we were actually in a case where there was a subarray boundary, the boundary between these two sensors in the GLM that stretched across the south central Iowa area. And there were several storms that then moved across this boundary. And so it provided a nice opportunity to look at how the geostationary lightning mapper flash densities may have changed, and how forecasters may interpret this kind of a product on the fly here. So looking for pixels that are nearer at saturation, you may get lower detection efficiency. However, in the subarray boundaries, it becomes this almost a catch-22, where it's actually more sensitive, but also can saturate more easily. So forecasters noting these storms moving over the boundary and being aware of that, they were able to then compare this information with the ground-based lightning networks to better interpret the GLM data with time, especially the GLM flash extent density product there you'll see in the bottom left of the animation. And the forecaster just noted in the blog post, just knowing the location of these boundaries. Many of the forecasters we talked to didn't really know that the subarray boundaries were a feature that they could be looking at. In that case. So that was quite notable from this day. Advancing next here, I think we'll go to our next product. This is called Gremlin. I believe there was a talk about 2 weeks ago about Gremlin also in the Satellite Book Club from Scott Lindstrom and Kyle Hilburn. But this is the GOES radar estimation via machine learning to inform NWP. And while it's a fun acronym, it actually has some really nice utility here when looking at synthetic radar imagery derived from satellite imagery. Notably, it uses the ABI water vapor and infrared bands along with the GLM group densities as a part of the GLM flashes. And this is trained against the MRMS composite reflectivity. So what you see there on the top left of that animation is a synthetic composite reflectivity, excuse me, data that's provided from Gremlin. This is a truly machine learned, derived from only satellite imagery. And so we can advance it forward now to the, and forecasters were looking at those convective cores and comparing them against the MRMS composite reflectivity image here in this 4-panel that we had created beforehand. We tried to create this image to show the water vapor and the long wave infrared imagery that was being fed into Gremlin along with the GLM data, and then showed a comparison there with the MRMS composite reflectivity. This was only the second day in the week of this week, so forecasters were still getting more familiar with the products themselves on that second day, and it was noted that you would look especially at doing a data quality comparison in between those two. When comparing those maximum reflectivity in the convective cores, especially looking for areas where Gremlin, whether it was a little bit ahead, sometimes the satellite information came in a little bit faster than what they expected, or sometimes because of the information provided from the water vapor and the long wave infrared channels actually obscured some of the signals that Gremlin would have picked up on, and actually had some suppressed reflectivity values. I believe if we advance one more here, I think there's another pop-up here. And this is where a forecaster noted that Gremlin's max intensity happened a little bit before a lightning jump that they noted, or an increase from the GLM flashes there. And so whether that was part of the, I haven't looked into whether that was just a natural increase because of the being ahead of Gremlin, but this is one of the things the forecasters are able to pick up on. These data are available in full disk only, and so they were provided in 10-minute intervals. Forecasters right away said that they would like to see this data in the CONUS and mesoscale scenes. That's something that actually we're working on and looking to do in the 2025 HWT, and that's still a work in progress. I'll move forward one here. Now, on this kind of a day, forecasters noted in their daily surveys that they didn't find Gremlin all that useful. And why? And I think it's because, and one of the things we thought about is that when you already have good radar quality, then the synthetic radar really add much value. And so this on the right here is just a 2-dimensional histogram showing how forecasters responded to 2 separate questions in the daily surveys. This is throughout the entire test bed. And you'll note that you can see when the radar coverage for those days were even average or great or excellent, that the utility of Gremlin was noted as being only roughly around slightly useful. We did do some data denial exercises by either doing radar outages at times in only a handful of events, or even providing DSS events in areas that we knew had poor radar coverage to begin with. And we noted that when you had terrible to no radar coverage or even poor, that the utility of Gremlin increased in that case, especially as forecasters shifted to looking more at satellite data. Now going to the next slide here, we can introduce the next product. This is Octane, the optical flow code for tracking atmospheric motion vectors and nowcasting experiments. So this is a product that has also been around, and I think has been Satellite Book Club a few times too. But this provides, based on the visible and infrared imagery from the GOES mesoscale scenes, can provide very high resolution motion vectors and those densities there, so we can get speed and direction readily from this 1 minute imagery. Additionally, last year, Octane provided this cloud top cooling and divergence fields. So you'll see the cooling as these kind of green blob that will pop up over where you would expect to see overshooting tops or those kind of updraft cores. You also will see the divergence fields there in the magenta to purples as well in that image. And the cyan is just an underlay in that image. And so forecasters were looking at this to watch for storm intensity as it goes. So advancing forward now, showing how Octane worked in this day. Early on, forecasters were looking for signs of glaciation using the Octane cloud top cooling, and you can see this in the top image here, where you see those those small little green pixels that are lighting up. That's areas where you have the cloud top cooling via the infrared imagery that's being tracked in time using Octane. There was some inhibition that was noted from the ACAR soundings, actually down in the Kansas City area. And so looking at that information also helped forecasters understand the overall evolution related to CI timing. There also was complementary signals from the day cloud phase RGB, you can see down there below, and then also from prob severe lightning cast, which I'll actually explain in a little bit later in this talk what that is. But those complementary signals help the forecaster be able to diagnose any kind of convective inhibition and how the synoptic forcing was competing against that in this environment. We advance one forward. This is another example that we'll have here with the severe warning decision with Octane. There were divergent signals from the Octane speed and also the divergence products. You also can look for rapid cloud top cooling, indicative of the updraft surges. And forecasters are able to use this to help them make warning decisions, understanding which storms to watch for. This case from a forecaster here in their blog post noted that Octane was helpful when diagnosing the storm and deciding to pull the trigger on a warning and influence their decision to do so. They also did note that this storm was a bit further from the radar, and so by being in that kind of position, they then were relying more on the satellite data in that case. Moving forward next, I think we'll go to our next product here, the Polar Hyperspectral Soundings and Microwave Data and ABI model, or PHS is what we've called it. This model has, again, I've also been talked about before, but this provides, this uses the information from the satellites in LEO, such as NOAA 20, NOAA 21, and takes that and feeds that in using a novel data assimilation scheme into a 4-kilometer WRF model. And so that was stationed across the central and eastern United States. And so looking at how using hyperspectral soundings from these polar orbiting satellites can provide information that can improve any kind of short-term nowcasting modeling scenarios. Advancing one forward here, we can show that the forecasters were looking at some spurious convection out ahead of that line on the day, looking at the PHS reflectivity that you'll see on the top right panel. This didn't seem to have a huge impact on the convective parameters on this day, mostly because you had this strongly synoptic forced environment. These kind of more subtle mesoscale features didn't tend to have as big of an impact in that regard. Advancing forward again, Forecasters also use PHS to look at the timing guidance for the CI location, along with just the overall evolution of these thunderstorms and kind of this quasi QLCS embedded supercell setup. And the forecaster noted that PHS was helpful for them when showing how the QLCS would evolve, and so that information, even just from this 4-kilometer WRF model with this extra information, seemed to be helpful in this scenario. And so having this, but comparing it against a baseline, is another thing that forecasters really wanted to see from this day. Advancing now next, we will go to the last product in our list, is the ProbSevere Lightning Cast model. This product, as many of the forecasters might know, is already operational. And we've been testing this now for the last few years. We tested some new things this year, but the ProbSevere Lightning Cast model takes information from the GOES AVI, from the visible, near IR, and infrared bands, and provides probabilistic output of lightning occurrence over the next hour. What's operational currently is greater than or equal to 1 flash. We also demonstrated this last year, the probability of greater than or equal to 10 flashes in those areas, somewhere over the next hour. And that's a 10 flashes per 5 minutes, the flash extent density kind of rate that's being compared against. So looking for more intense convection and where that was more likely. Additionally, forecasters had access to the Lightning Cast dashboard. These dashboards are available via a web display, and they're stationed at airports and various stadiums and other regions, common DSS points across the country. We also demonstrated this year that forecasters could get on-demand dashboards where they could enter in the location that they wanted, especially for our simulated DSS events that we also ran on these days. And they could drop points there and then look at that throughout the entire event. So advancing now to the next slide. Forecasters used Lightning Cast for quite a few nowcasting scenarios here, especially looking at those increased probabilities prior to CI. So we can see that quite well here. This is from the Kansas City CWA, where a forecaster talked about looking at the lower probabilities, but the 10 to 25% appeared at about 1856Z on this day. And they started seeing that first lightning flash by about 1928Z. And so for the lead time from Lightning Cast in this scenario seemed quite useful for them to be able to have a heads up on where to be looking for that developing convection and increase confidence there. Moving to the next slide here, I want to show you an example from that day of some DSS applications. So we had a DSS event that we had in north central Missouri. Can't remember what the event actually was, but we typically make up these kind of fake events, outdoor festivals and the like. And forecasters were providing then the information to a decision maker at that event, whether that's an emergency manager or just an event manager. And Lightning Cast dashboards help them to monitor increasing and also decreasing probabilities throughout this event. So a forecaster was able to provide the information of those decreasing probabilities that you can see there with the yellow and red lines, and also the pink lines there as well is the max probability from Lightning Cast within a 10-mile radius, along with providing the GLM information that you'll see there with the orange and white dots. And so forecasters could then provide that information, this probabilistic information, to their partners in this kind of a case. We also asked forecasters how much lead time Lightning Cast provides them throughout the test bed. And this is kind of related to that previous image. The forecasters generally found that they could see about 10 to 30 minutes, you'll see there, of actionable lead time for initiation and advection, but we also saw quite a few forecasters noting over 40 minutes of lead time. This is most likely dependent on the scenario in which Lightning Cast is being applied. Where you have more rapid CI, you may see that kind of 10 to 30 minute range. Where things are more slow to develop or tied to terrain, then you may see those longer lead times of over 40 plus minutes in those areas. It just kind of depends on your overall convective scenario. The forecasters were able to note that lead time and how to take that information and apply that. Going to the next slide here, So now just getting to our overall experiment takeaways, and we can just go ahead and put all 5 of those up here from Gremlin and from GLM, from Octane and PHS, from Lightning Cast 2. With the GLM background and data quality product, just familiarity with those subarray boundaries was the big learning point for forecasters in that week. So just knowing where they are, if they're in your CWA, how to handle those was a factor there, and forecasters would then use the background and data quality product for those. With Gremlin, the greatest impact of Gremlin was as it was designed was in regions with poor to no radar coverage, and so forecasters recommended producing these on the CONUS and mesoscale scenes to look at more kind of finely tuned areas, especially for any kind of developing convection and how to monitor that. In some cases, Gremlin may actually lead any kind of MRMS composite reflectivity data in those scenarios. From Octane, it was useful for monitoring those developing convection updraft trends, and even in some cases, identifying mesoscale boundaries in some more subtle regions of mesoscale ascent. And then the cloud top cooling product was especially noted for being useful for initiating convection. With the PHS model, providing that extra information and context in mesoscale kind of meso-analysis format, leveraging that in pre-convective environments, especially alongside the operational models. And with Prob Severe Lightning Cast, using those static and on-demand dashboards were helpful, or help to then communicate hazards to partners, and then also the training for different applications and also display configurations. We played with that a little bit this year too. And that wasn't as noted on these kind of days. We usually did that later in the week. But we'll note here that, yeah, as this product transitioned into operations, training for these data sets and how to apply them was also noted as being useful. So that's everything that I had from taking this one event and showing how it applies to everything we learned in the test bed in 2024. We're really excited then to take that and move it into 2025 as well, with testing new different products and applications and designs. So thank you all so much for your time and for doing this. Thank you for all the little clapping reactions too. And I'd be happy to take questions or turn it over to the organizers as well. Thank you. Oh, I'm sorry. Actually, one more thing I want to say. Sorry. I want to make sure I have acknowledgements. So I want to acknowledge there's about 40 people that helped to put this on. I'm just one person kind of trying to play traffic cop to organize everybody. But so many people in CIWRO, SBC, and NSSL from the GOES-R programs. We had great developers to work with, along with NWS forecasters that provided great feedback. And then also to Justin Monroe and Jonathan Madden, who ran our cloud AWIPs and did that really well. You can get the final report. It's available at the DOI there. I'm going to drop a link in there as in the chat as well, along with forecaster blog posts. If you want to read those directly, you can get the information directly from the forecasters. You don't have to have a middle person to do that either. You can just read that directly. The references to the products that were mentioned. And so yeah, thank you. My apologies. That's all that I have now, and I'll turn it over to the organizers.
All right, thank you, Kevin, for such a great presentation. We want to encourage attendees to stay on for the discussion. We especially encourage participation from those in the field offices as well as regional headquarters. We encourage everyone to change his or her meeting layout to tiled as well and select hide tiles without video. Emily will be posting in the chat shortly a link for the SBC feedback form. We want to remind attendees to submit their questions or indicate if they have a question verbally via the chat. In the next week, so a week from today on Thursday, February 20th at noon Eastern Time, Bill Line, a physical scientist and imagery science team lead from the NESDIS STAR, will discuss operational applications of the VERS imagery for CONUS offices. We also want to encourage attendees to contact the TowerS team. This consists of Kashad Bowman as well as Emily Maddox for questions about the SBC or for configuration of satellite products. So with that, we'll begin our discussion period. So in the chat, there was a comment from Dan Lindsay that I did want to bring up before we start questions. So Dan Lindsay had mentioned that the main target for Gremlin's areas is for areas with no or poor radar coverage, like over the ocean, and in other countries that don't have radar coverage, as well as areas with radar gaps. But comparing to MRMS, reflectivity is a great way to validate this model. We also had a question in the chat from John Stopke asking about LightningCast dashboard and where it was available. The link for this was posted later in the chat by Thomas Hillquist. It's on one of the SIMS Wisconsin's pages. Like I said, it is linked in the chat. It looks like Kevin also linked the HWT report in the chat as well. So we have one question from Nicholas Carr. He says, you mentioned that on-demand LightningCast dashboards for IDSS points were created for the experiment. And is that functionality available on the current public viewer on the web? I see stadiums and aviation points at the moment.
Yeah, that's a good question. So for Nicholas, those on-demand dashboards, you actually, if you're on that page that that Thomas Hillquist had mentioned earlier, or on that link at the top of the page, there should be an on-demand dashboard request form. That's for NOAA only. So as long as you're signed into your NOAA account, you can then make that request and pull those up there. So at that same link that's linked above, here I'll put it in there again, I think just for completeness. But at that link, at the top of the page, there should be a request form linked there.
All right, thank you, Kevin. Our next question is for WFOs in the central US, should they be looking at Gremlin from the GOES-East or the GOES-West satellite?
Yeah, that's something that on the day we looked at, we didn't look at too much, but it is one of the things later on actually we did look at, and it really does depend on the scenario and what you're looking at. If you can use both, that's great. But there were some days where we would see like splitting supercells in the anvil shield from the GOES-East perspective would actually cover up that northward split in some cases and actually delay when that would be picked up by Gremlin. But from the GOES-West position, having kind of this shot a little bit further underneath that anvil, it was able to then pick up on that a bit sooner. So it depends really on what you're looking at, especially if you're in more stronger sheared environments. Then looking at it from the GOES-West perspective, especially in like the central U.S. and central tier central southern plains, from there that may provide some additional information. But it kind of depends on what you're after.
All right, thank you, Kevin. I have a quick question for you. So with the LightningCast, the contour features, are those currently parallax corrected?
They should be available as like in the native resolution, like native satellite data, and then also there is a parallax corrected version that's applied there. It just takes at a standard 9 kilometers in height and parallax correct against that. So you should be able, as long as that's available in both ways in AWIPS. I'll have to double check that, but that as long as you have the parallax corrected data available, yeah, you can overlay that directly with your radar data in that setup.
Awesome. So just a follow-up from one of your final points that you had mentioned that especially the LightningCast model, you guys are looking for kind of more training features and such. I know WDTD just released an updated GLM module where we put a good section of LightningCast product in there, as well as some operational uses. But if anyone in the field, as well as yourself, Kevin, if you hear anything regarding some more training opportunities there, please let us know at the Warning Decision Training Division. We would gladly like to add those into our models.
Yeah, absolutely. The being able to really demo these kind of products, especially a product like LightningCast, ahead of it becoming operational for training applications has been really useful, especially finding where LightningCast excels and then where a forecaster can look for different kind of caveats or limitations of the model. Especially being satellite based, there are some times when satellite features don't get picked up on that are related to convection, especially when you have things like anvil debris. So those kind of limitations right now are something that LightningCast faces, and forecasters, we want them to be aware of. So yeah, as long as we keep finding those kind of applications, we'll find all sorts of weird stuff sometimes when looking at the data in this kind of live format. And so some really fun and interesting examples tend to come out of kind of doing it in this way.
Awesome, thank you, Kevin. So yeah, John Stockcoat had also mentioned that both are available. It's available both ways, so both parallax and non-parallax corrected.
Okay, great.
All right, so it looks like that might be the end of our questions. If anyone has any additional questions, I'll give you a moment to throw those into the chat. All right, looks like that's it. So with that, I'll pass it back to Liz for final remarks.
Thank you, Jessica, and thank you, Kevin. Kevin, thank you for presenting at the SBC today, and thank you, Jessica, for your excellent facilitation during today's discussion. As previously mentioned, please remember in a week from today, Bill Line, physical scientist and imagery science team lead from NESDA STAR, will discuss operational application of VIIRS imagery for CONUS offices. Thanks, everybody. Hope you have a great day.